Okay, we're back on page 85, and we're going to do a couple more of these examples with our continuous graphs, listing our domain and our range. I rewrote this up at the top. I want to remind you that what we're writing for domain and range are actually and inequalities. And inequalities. They have more than one condition that they have to meet. So in this example that we did on the last example, our inequality was that x is less than or equal to 4, but it's also greater than -2. So it has two endpoints and a condition dictated by where the x values are on the graph. We talked about domain left to right, dollar ribbit, and we went on our x-axis. The domain was from this point right here, which was -2, all the way to this point right here, which was +4. So if we look at the next graph, again, this is a continuous graph because it doesn't have any breaks where it starts and where it ends. It's continuous. And if we want to list the range, writing an and inequality, again, we have to look at where it goes on the horizontal, left to right. So if we look, this is right here, this guy right here, and this guy right here are the endpoints on the x-axis. So -3 is our smallest x, and our largest x is +3. And I have to note that this -3 should have a line underneath it because his circle is filled in. So our domain is greater than or equal to -3, and it is smaller than +3. When we look at the y, we are looking at the ribbit, the range, bottom to top. Maybe I'll go grab another color for bottom to top. The y, we look at, here is the top of the y on the y-axis, and here is the bottom of the y-axis. So again, we start with the smallest y. It's -3 also. It is less than or equal to, and we're going to use y. Instead of our variable x, we're talking about our outputs. We're using a line underneath the greater than or equal to because the dot is closed in. And where does the y end up? The y ends up at 1 right here. This guy right here. This is the highest value of our y. So we have -3 all the way up to +1. And it does not include +1 because the circle is an open circle right here. So see if you can do number F, example number F, and I will come back and do it with you in either the next video or a continuation of this video. Okay, and I'm going to do one more example. I'm going to go ahead and do F on this video. This is our parabola function. I hope you're thinking maybe the equation of this graph would have an x squared in it because it's a parabola. It's continuous because from start to finish, there are no breaks in the line. So we know that when we write our domain and our range, we are going to have an and type inequality that looks similar to the problems that we've already done with D and E. So if we're inspecting where the domain and the range go, if we do the domain first, we're looking where is the smallest point on the x-axis to the largest point on the x-axis, where we find all of the points. All of the points lie between this x and this x. So if we list it, we get x is less than 2 and x is greater than -2. And both of our circles are open, so we don't put a closed line underneath either one of them. Looking at the range, similarly, we're looking at the largest range, top to bottom. So our range, this is the smallest y that's on our graph. That's -1 on the y-axis. And the largest on the y-axis is less than or equal to 3, because this point right up here is right on 3, and it's not an open circle. So even though it doesn't have a big dot on it when the graph started out, it is part of our range. So our range is between -1, -1, not including -1, up to and including +3. So let's look at this example here, and then we'll stop, and I'll let you guys do H and I for discussion in class. Again, this is continuous. It's a parabola. I'm thinking an x squared equation, whatever it may be. I'm looking at the domain, and I'm noticing that my graph does not stop. Unlike these graphs on the top 3 examples that had an end point and a starting point, this graph is going on forever and ever, which tells me that it is including every single point on the x-axis. Every point on the x-axis will ultimately be a part of this graph. So if that's the case, there are no points excluded, and we can write the domain as all real numbers. If we look at the range has a bottom. His bottom is -1. There is no point on this graph that is going to have a y coordinate in an ordered pair that's anything smaller than -1. But his upper bound, the y upper bound going up and down, again, this graph has no end, so we don't know where it's going to end, but any y is fair game for this graph. So we would say that the range of y is greater than or equal to, because this -1 right here is on our graph, the range is greater than or equal to -1. Okay, I'm going to stop now and let you guys do H and I for discussion in class. Thanks for watching.